2.7 section, which is absolute value functions and graphs, is going to be very, very similar to 2.6 using our transformations, but instead of having parentheses, you'll notice that I instead have absolute value bars. Everything else is going to be the exact same. So this A is in charge of stretching or compressing, this H moves it left and right, and this K moves it up and down. So please do write this again. And we're going to go through some examples of using these transformations. So for this first one, I have y equals the absolute value of x. My new equation is y equals the absolute value of x minus 4. So if I were to graph both of these, they're going to be V-shape. But what changes with the new one when I subtract 4 at the end, that is in the K spot, so I'm moving it down 4 units. Okay, and you don't need to graph both of them if we start to know our transformations, but if you want to, you can take a look at both of the graphs. Now number 2, my two equations, taking a look at to get from this first one to this new one, I'm adding 2 at the end, so to add 2 in that K spot, I'm moving it up 2 units. Now, this next one has 2 transformations. I'm adding 2 inside, so that's in the H spot, so that moves it left and right. It's the opposite of what you would think. So it's moving it to the left 2, and then this plus 3 is moving it up 3. Now, if I want to take a look at this graph, I would start with going to the left 2, going up 3, and I make that vertex. Now notice there's no number in the A slot, so the number that I could put there is just 1. So think of that A as just your slope. So I'm going up 1, over 1, up 1, over 1, or then reflect that over, up 1, back 1, up 1, back 1. We know it's going to be a V shape because of those absolute value bars. Whenever there's those bars, we know it's going to be a V shape. So this next one, we're going to take a look at the exact same process. This minus 2 means that it goes to the right 2. This plus 1 means that it goes up 1. So we make that vertex to start off with. We go to the right 2, up 1. We make that point. There's no number in the A slot, so it's just 1. So it goes up 1, over 1, up 1, over 1, and then reflect those points over this axis of symmetry. So up 1, back 1, up 1, back 1, and we get our graph. This next one has a number in the slots. You'll notice it's not moving left or right, it's not moving up and down, but it is compressing by a factor of 1/2. So how that's going to look, we would start at 0, 0 because it's not moving left, right, it's not moving up, down, but our slope is going to be up 1 over 2, up 1 over 2, or up 1, back 2, up 1, back 2. So it's going to be, when it's compressed, it's going to be wider or flatter. If it's stretched, it's going to be a more narrow V. The next one, you'll notice it is multiplying by 3 out front, so it's stretched by a factor of 3, and so you'll notice our V is a lot more narrow. It's going up 3 over 1 or up 3 back 1, so the graph looks a little bit different. Now let's start combining these transformations together. So this one has 3 different transformations. The 3 in the A slot is stretching it by a factor of 3. The negative 2 is moving it to the right 2, and this 4 is moving it up 4. So then from here, I'm going to take a look and answer all these questions. So to start off with, I went to the right 2, I went up 4, so I made that point, and then my slope is 3 over 1, so up 3 over 1 or up 3 back 1, and I get that V shape. So that would be what my graph is looking like. And then if I answer these questions off of it, this point right here is considered my vertex. So if I label that, it's 2, 4. My axis of symmetry is that dotted line that splits my absolute value graph right down the middle. It's going to be whatever this x value is. So it's x equals 2. And then my transformations, this 3 is stretching it by 3, this 2 is moving it to the right 2, and then up 4. Okay, notice that the vertex is going to be the opposite of this number and the same as this number. Let's try another one. So I have y equals 2 times the absolute value of x minus 1 minus 3. So I'm stretching it by 2, I move it to the right 1 and then down 3. So my vertex is going to be the opposite of this number and the same as this number. So positive 1, negative 3. My axis of symmetry is going to be whatever the x value is, so x equals 1. My transformations, we said it was stretched by a factor of 2. It moved to the right 1, and it went down 3. And then if I were to graph it finally, I'm going to go to the right 1. I'm going to go down 3, make my vertex. My slope is 2, so up 2 over 1, or up 2 back 1, and then I make my V from there.